All right, so in this, all right, so there are a few other ways to factor. You have your difference of perfect cubes, your sum of perfect cubes, and your difference of perfect squares. All these, at some point in time, you were introduced to them in your math career. Okay, let's say you're given a binomial, right? A binomial has two terms, and one of them, actually both of them, are perfect cubes. In other words, when you multiply a number by itself 3 times, you get this result, such as x to the third minus 27. Okay, to be able to factor this, you want to follow the formula that you see in black. Okay, now a and b represent the cube root of each of these terms. What's the cube root of x to the third power? It's x. X times x times x gives you x to the third. So a represents x. What about 27? What's the cube root of 27? 3. 3 times 3 times 3 is 27. So a is x, b is 3. And so pretty much you're plugging in x for a and b for 3 into this formula. Okay, this is the formula of how you actually factor perfect cubes. Okay, so whenever it's a minus, it's always going to be a minus b. So in this case, it's going to be x minus 3. And then you fill in everything else. What's going to be a squared? X squared. What's a times b? It's actually going to be plus 3x. The sign doesn't go with the 3. The reason why it's a minus is because it was originally a minus to begin with, but the sign, it's just whatever the values are there. And then what's b squared? 9. Now, you're not going to be able to factor this back end, this back part, and so you're done. That's how you factor perfect cubes. And that's the formula that goes along with it when it's a subtraction in between them. Okay? Let's look at the next one. It's the sum of perfect cubes. What's the cube root of 8? What's the cube root of x to the third? And what's the cube root of 125? 5. So there you go. You have your a and your b. The cube root of 8x cubed is 2x. The cube root of 125 is 5. So your a is 2x and your b is 5. So you fill in your symbols and you pretty much fill in the rest of the formula. What is a squared going to be? Say it again. 4x squared, because you're basically taking 2x and you're squaring it. So 2x times 2x is 4x squared. What's going to be a times b? So it's going to be a minus 10x. And then what's b squared? Plus 25. And that's it. You're done. You can't go any further than this. So it's important that you're able to recognize what your a is, what your b is, so then that way you'll be able to factor. So in this case, a was x, b was 3. In the second case, a was a 2x, and b was a 5. Be very careful when you have a coefficient in front of that first term. Questions on the cubes and how to factor those? The last one, difference of perfect squares. This one's an easy one, because pretty much all you got to do is just take the square root, write it twice, one with the plus, one with the minus. What's the square root of 4x squared? 2x. What's the square root of 25? So one's a positive, one is a negative. And that's it. All right? There's one more other type of factoring that we'll talk about next, but I also want to make sure that I point out GCF is still always done first, no matter what. So you want to look to see if there is a GCF, you factor it out, and then if it's still perfect squares or perfect cubes, then you follow the formula. Okay? All right. Your last case of your special cases. Okay? You have your perfect square trinomials. You have your perfect square trinomials. All right, so in these types of problems, okay? I don't want you guys to think that, oh, okay, well, if you look at the first one. The first one is simple enough, yes? Some of you guys may be like, okay, well, I can just figure out what two numbers multiply to give me 81, that add together give me 18. Boom, 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 I'm done. What about the bottom one? It can still work, but it might take a little bit longer. All right? So, these special cases, okay, these are called perfect square trinomials. This is when the first term and the last term, of course, when you take out a GCF, but this is when your first term and your last term, they're both perfect squares. And then the middle term is 2 times the value of A and B. Okay? What's the square root of x squared? X. What's the square root of 81? It's 9. When I multiply those together and multiply them by 2, what's 2 times x times 9? 18x. And it should be the middle term if they are perfect square trinomials, which means they can be written as a plus b, the quantity squared. Okay? So if a is x and b is 9, it's just going to be x plus 9 squared. Again, yes, you would get the same thing if you did your x, put 81 at the top, 18 at the bottom, and figured out that the two numbers were 9 and 9. You would just get, x plus 9 times x plus 9, which is x plus 9 squared. It works. If that's shorter, then that's great. But if it's like that bottom one, it's a little bit more involved, okay? But hopefully you can recognize that, wait, 64x squared is a perfect square. What is it? It's 8x. And 9 is a perfect square. What's square root of 9? When I multiply 8x by 3 and multiply it by 2, do I get 48x? Yes, we do. So this is a perfect square trinomial, which means since it's a minus here, that means I'm using the bottom formula. So then my answer is just going to be 8x minus 3 squared. Yes, you could get the same. Yes, you will get the same thing when you do 64 times 9, make your x. But now you're trying to figure out, what two numbers multiply to give you a large number that add together just give you like a negative 48. Okay, it might not be as easy as just, being able to recognize those things. All right? Yes. Yeah. Okay. So these are all examples of perfect square trinomials. Okay, a perfect square trinomial is when the first term is a perfect square, the second term is a perfect square, and the middle term is 2 times whatever those perfect squares are. Okay, so if you can recognize that, okay, if I take the square root of the first term and the last term, so that was x and then that was 9. If I multiply them together and double them, because that's what the 2 represents, then I should get the middle term. If I do, then they are perfect square trinomials, which means that I could just easily use this formula and then they're factored. Okay? So then that's why we were able to get x plus 9 squared, pretty straightforward. Same thing with the bottom. These are both perfect squares. That becomes 8x. The 9 becomes 3. Again, I need to multiply them by 2 because 2 is a part of the middle term. And that's how we get 48. So this becomes 8x minus 3 squared. So whatever A is, whatever B is, they just go into this formula. Okay? Questions on any of the factoring? There's one other type called grouping, but I don't know if we're going to do any grouping ones. But if we see it in a future test, then I'll make sure I review grouping as well. But grouping is the last one. All right, we're going to do some practice. I want you guys to do this on your desk, okay? So this pretty much is going to be like a reference page, okay? If you want to even add in, like slide, divide, bottoms up back in here, you'll have it all on one page right there, so you won't have to flip back, okay? But I want you guys to do this one on your desk, yes. For this first one, always look for your GCF. Is there one? What is it? It's 2AB. Not only are 8 and 6 both divisible by 2, but each term has at least one A in common and a B in common. So when I factor out a 2AB, what does that leave me with? Minus 3 what? B. Okay, so I always take out my GCF no matter what it is. Yes. Okay, so so this is one of your terms. So you basically have, if I break it all the way down, that's your first term. 2 times 2 times 2 is 8. 8 times A is A squared, and then you have a B. And then if I break down 6, that's the next term. So you always want to look for your GCF, what they have in common. Both terms have a 2 in common. Both terms have an A in common. And both terms have a B in common. So because they have those 3 pieces in common, you factor that out. And whatever's left over, 2 times A, stays on the inside. 3 times B stays on the inside. Now, from here, you want to look at the inside. Are these perfect squares? Are they perfect cubes? No. So because it's neither one of those two things, and it is a binomial, it's not a trinomial, I can't do anything else from here. So then this is my final answer. Then you keep going using one of the formulas. But if it's not, you stop here and you're done. Any of the ones that we do on your desk, if you want to add them into your notes, by all means, go ahead and do so. Clear your desk. Here's the next one. Remember, this is a review of all factoring. What's the first thing you look for when you factor? You look for your GCF. Is there one? No. Now you look. Okay, this has 3 terms. It's a trinomial, so I'm not dealing with any cubes or perfect squares. This could be a perfect square trinomial. Yes or no? No. Why not? Because 15 is not a perfect square. So this is a regular, just the X. What number goes on top? What number goes on the bottom? What are my 2 numbers? 5 and negative 3. Okay. So then I get W, plus 5 and W minus 3. Can I go any further? No, but then that's solving. All right. And real quick, you can always check by foiling. W times W, W times negative 3, 5 times W, 5 times negative 3, combine like terms, and we get the original problem. Okay? So you can always check. If you ever ask, am I right? Foil. See if you're right. Clear your desk. Here's the next one. Now with this one, is there a GCF? What is it? Okay, so I factor out a 2. When I factor out a 2, what does that leave me with? Okay, so I took out my GCF the way it was. I didn't change anything around because it sounded like some of you guys are trying to change it around on me. There's nothing wrong with that. I'm just going to leave it this way though. Now on the inside, it's a binomial. It's not a trinomial, so I can't do the X thing. X is only applies to trinomial. And I've already taken out my GCF. When I look at these 2 terms on the inside, they're what? A little louder? They're perfect squares, okay? What's the square root of 4? What's the square root of 9G squared? 3G. So 2 represents my A in that formula for difference of perfect squares, and 3G represents my B. So when I write this, I bring down my 2, and remember, difference of perfect squares, the formula is, where is it? A plus B, A minus B. So here I need A plus B, A minus B. And then if I look at the inside of the parentheses, can I go any further? Are these perfect squares? Perfect cubes? So then I'm done. I can always check to see if I'm right by foiling those two parentheses and then distributing over the 2, and I should get my original problem. Okay? Does everybody understand? Because I saw that a lot of people were kind of stuck at that part. Okay? Kind of go through a series of questions in your head. Okay? After you've taken out the GCF, is it a binomial or is it a trinomial? Okay? So then once you determine that, if it's a binomial, you want to see if they're perfect squares or if they're perfect cubes. If they're perfect squares, it should be a minus. All right? Then you go into the factoring. But if it's cubes, is it a minus or is it a plus? Because you need the right formula. If it's a trinomial, look at the first term and the last term. Are they perfect squares? Because if they are, then you want to use your perfect square trinomial formula. But if they're not, then you want to just go ahead and do the x. Okay? Questions? All right. Let's look at this one. First thing you look for, GCF, is there one? No, it doesn't. Not between all three terms. In order to have a GCF, it has to apply to all three terms, and there isn't one. So, it's not a binomial. So I can't use difference of perfect squares or difference of sums of the cubes. So I can't use any of those first three that I showed you from earlier. It might be a perfect square trinomial. The first term and the last term are both perfect squares. What's 4g squared? 2g. What's the square root of h squared? H. Now, if this is indeed a perfect square trinomial, then when I multiply 2 by 2g and by h, I should get the middle term. Do I get 4gh? So this is indeed a perfect square trinomial. It is one of the ones that's going to have a plus in between them. So then I just take my two perfect squares, which were 2g and h. I put a plus sign in between them, and then a square on the outside. Remember, any one of these you guys can add into your notes, okay? Any one of these you can add into your notes. And anytime there is a variable on the back end of a problem, that just means your last term is going to also have a variable. Yes, that can happen, okay? All right. Last one. Okay. Is there a GCF? No, there's not a GCF. I have an a cubed and a 64. Both do not have a variable and both do not have a number. Now, this is a binomial because it has two terms. Are these perfect squares or perfect cubes? They're perfect cubes, and on top of that, it's an addition symbol. So that means you're going to be using the one that looks like this. It breaks down to be a plus b times a squared minus ab plus b squared. What's a going to equal? A. And b is going to be? So I go and I plug those things in. So this is going to be a plus 4 times what? A squared minus 4a plus 16. And I cannot go any further than that. That trinomial that's there, it's always going to be non-factorable. Okay? It's always going to be non-factorable. So you'll leave it as a squared minus 4a plus 16 because there are no numbers that multiply to give you 16 that add together to give you a negative 4. Okay? So this is our review of factoring, okay? GCF, slide, divide, bottoms up, make the X, perfect squares, perfect cubes, perfect square trinomials.